This is your second set of notes for cell transport and the final set of notes for this unit. You've made it. Here we go. I'm going to start towards the end of the last set of slides, but it is the same set of slides as the previous video. So we're going to see what happens when water moves through a semi-permeable membrane, but solutes do not, right? Because that membrane is permeable to small non-polar things, water being an exception, but not impermeable to larger polar things. So here's what happens. Osmosis happens, right? Osmosis Jones, ooh. Water will move into or out of the cell, right? Just some vocab that you've seen before. Water in this case is referred to as a solvent. Remember, it's a universal solvent. It dissolves everything because it's polar, and a lot of things are also polar. The solute is what's being dissolved in the water. So for us, for these examples, usually we're going to be looking at things like salt. However, sugar, amino acids, other larger molecules that might not be able to pass through the membrane on their own are also considered solutes. And there are three vocab terms that you need to be masters of: isotonic, hypertonic, and hypotonic. If the solution that the cell is in has the same solute concentration, so the amount of salt, as the cell's solution, those two are said to be isotonic. The solution with the higher solute levels is hypertonic. Like if you're hyper, you have a lot of, I don't know, like if kids hyper, they have a lot of energy, right? So if you're hypertonic, you have a lot of solute. If you're hypotonic, you have a low amount of solute. So let's see these three things in action. Here's a beaker of water, right? So these little blue dots are our water molecules. And in that beaker of water, 10% of the there's a 10% salt concentration. There's a 10% salt concentration, right? Well, the things in the beaker have to add up to 100%. So if 10% of it is salt, that means the rest of it, 90%, must be water. And that's what we're showing you with these blue dots, right? Inside the cell, remember this is doesn't look like it, but it's supposed to be a cell. By the way, this is a semi-permeable membrane. Water can go through, but the salt cannot. You also have 10% salt. And again, inside the cell, things have to add up to 100%. So that means the rest of it, the remainder, is water. 90% water. I'm not going to write water because I'm running out of space, but it's water. 90% water. So if you look, you say, okay, they've got the same amount of water. They've got the same amount of salt. Iso means same. So these two solutions are isotonic to each other. They are isotonic to each other. And water is going to move in and out of the cell equally, in both directions equally, the same amount equally, and that's because water is in equilibrium. A lot of people forget that water still moves. A lot of times people will say, oh, well, it's an isotonic solution, it's reached equilibrium, so the water is not going to move at all, right? That's wrong. The water still moves, but it moves more or less equally in both directions, so it kind of appears to not be moving. In a hypertonic solution, you're going to have, remember, the solution here is hypertonic, so outside the cell is going to be hypertonic. Let's see what that looks like. All right, here's our cell. We're going to start in the cell this time. So it actually looks like the cell is the same. 10% salt, which means 90% water, because again, they have to add up to 100%. But outside the cell, This is a saltier solution. It's 20% salt this time, which means there's only 80% water. Right? So because the outside of the cell, the solution in this beaker, is saltier, it has more solute, we say that the solution is hypertonic. The solution is hypertonic. And the cell, you guessed it, or maybe you didn't, is hypotonic. Hypotonic. Water is always going to go from a higher water concentration to a lower water concentration. This is just diffusion, it's osmosis, right? The salt's not going to move, it's stuck. It can't fit through the membrane, but the water can, right? So the water moves out of the cell into the solution. It goes from a higher 90% concentration to a lower 80% concentration. This is the opposite. So here, notice that the cell now has 20% salt, which means 80% is water. And the solution only has 10, which means there's 90% water. Okay, well, which is saltier, the inside of the cell or the outside? Well, the inside of the cell is saltier. So the inside of the cell is now hypertonic, whereas the solution, because it has less salt, is now hypotonic. So we say the solution is hypotonic. Well, which way does water move? Well, there's a higher concentration of water outside the cell. There's a lower concentration of water inside the cell. So water will move into this particular cell from a higher 90% to a lower 80% concentration. And in this case, whereas the other cell would have shriveled, this cell could potentially explode. It could pop. So let's do an example. Here's a cell in a beaker, and that's water. There's the cell. I would encourage you to draw this. Let's say that let's go ahead and label these. Salt. Remember, the membrane around the cell is semi-permeable, so water will move, but the salt won't. Let's say that the salt concentration equals 5% outside the cell. Inside the cell, the water concentration equals, let's say 70%. Pause the video, fill in the percents, label all the vocab, and tell me which way water moves. So go ahead and pause and do that now. All right, hopefully you've done that and you've unpaused. So here's what you should have done. The first thing you're always going to do in these examples is do your calculations. So we're going to calculate the amount of water outside the cell. Well, they have to add up to 100%, right? So outside the cell, water must be 95%. Inside the cell, they actually gave you water. I gave you water, so you actually calculate the salt. That has to be 30%. Again, because they add up to 100. The second step is to label your hypotonic and hypertonic sides. So where is there more salt? Well, there's more salt inside the cell. So the inside of the cell is hypertonic. The outside of the cell, which has less solute, less salt, is hypotonic. And the third thing is to show the direction of water movement. Water movement. Water goes from a high to a low water concentration. Right? So where is there more water? Well, there's 95% water outside the cell and only 70% inside the cell. So there's a huge concentration gradient here. Water is going to go from a high to a low concentration. It's going to enter the cell, and this cell is going to swell or burst. That's how you do these problems. And we'll work more on this in class, and I will see you in class.